Welcome to Certified Information Security's training and certification program for the Certified NIST Artificial Intelligence Risk Management Framework 1.0 Architect. This is the third part of 4 of the introduction to the training and certification program. I'm Allen Keele. Thanks for joining me. So you've heard me talk about the AI risk management lifecycle. Well, we need to go ahead and get a basic understanding of that so that way we can see as we look through the core with our 4 core functions where those play out in the AI life cycle. We'll begin with looking at roles and responsibilities within that life cycle as well. Identifying and managing AI risk and potential impacts, both positive and negative, requires a broad set of perspectives and actors across the entire AI lifecycle, which is why we need to look at roles and responsibilities and how they're allocated to the AI lifecycle from all spectrum of the organization. Ideally, AI actors will represent a diversity of experience, expertise, and backgrounds, as well as comprising demographically and disciplinarily diverse teams. The AI risk management framework is intended to be used by AI actors across the AI lifecycle and its dimensions. So NIST provides this graphic to illustrate the AI lifecycle. The 2 inner circles show AI systems' key dimensions, and the outer circle shows AI lifecycle stages. Ideally, risk management efforts start with the plan and design function in the application context and are then performed throughout the entire AI system lifecycle. There are 4 key dimensions in an AI lifecycle system. The AI dimensions are application context, data and input, the AI model, and task and output. AI actors involved in these dimensions who perform or manage the design, development, deployment, evaluation, and use of AI systems drive the AI risk management efforts. So let's look at some of the context for AI actors involved in AI design. AI design tasks are performed during the application context and data and input phases of the AI lifecycle. AI design actors create the concept and objectives of AI systems and are then responsible for the planning, design, and data collection and processing tasks of the AI system so that the AI system is lawful and fit for purpose. Tasks in AI design include articulating and documenting the system's concept and objectives, underlying assumptions, context and requirements, gathering and cleaning data, and documenting the metadata and characteristics of the data set. AI actors in this category include data scientists, domain experts, sociocultural analysts, experts in the field of diversity, equity, and inclusion, and accessibility, members of impacted communities, human factors experts, governance experts, data engineers, data providers, system funders, product managers, third-party entities, evaluators, and finally, legal and privacy governance actors as well. So again, when you're trying to consider who needs to get an understanding of how to play a part in AI risk management, there's your first set of individuals that need to understand AI risk management as this course is teaching it. So now we've moved on from AI design to AI development. AI development tasks are performed in the AI model phase of the lifecycle. AI development actors provide the initial infrastructure of AI systems and are responsible for model building and interpretation tasks, which involve the creation, selection, calibration, training, and/or testing of models or algorithms. AI actors in this category include machine learning experts, data scientists, developers, third-party entities, legal and privacy governance experts, as well as experts in the sociocultural and contextual factors associated with the deployment setting. Following the design and development phases, we now look at the AI deployment category. AI deployment tasks are performed during the task and output phase of the lifecycle. AI deployment actors are responsible for contextual decisions relating to how the AI system is used to assure deployment of the system into production. AI deployment tasks include piloting the system, checking compatibility with legacy systems, ensuring regulatory compliance, managing organizational change, and evaluating the actual end user experience. AI actors in this category include system integrators, software developers and end users, operators and practitioners, evaluators, and domain experts with expertise in human factors, sociocultural analysis, and governance. And once we've deployed the AI system, we naturally need to now operate and monitor it. Operation and monitoring tasks are performed in the application context, operate and monitor phase of the lifecycle. These tasks are carried out by AI actors who are responsible for operating the AI system and working with others to regularly assess system output and impacts. AI actors in this category include system operators, domain experts, AI designers, users who interpret or incorporate the output of AI systems, product developers, evaluators, and auditors, compliance experts, organizational management, and members of the research community at large. Despite all of the care and caution that we exercise during the design, development, deployment, and operation of AI, we can't really be sure that the AI system is trustworthy if it hasn't been thoroughly tested first. So this is where test, evaluation, verification, and validation comes in. These are tasks that are performed throughout the AI lifecycle, and they're carried out by AI actors who examine the AI system or its components, or detect and remediate problems. Ideally, AI actors carrying out verification and validation tasks are distinct from those who actually perform the test and evaluation actions. TEVV tasks can be incorporated into a phase as early as design, where tests are planned in accordance with the design requirement. You can learn more about test, evaluation, verification, and validation at the link provided on this page, where NIST provides further detailed guidance on this process itself. And then we also have roles devoted to human factors. Human factors tasks and activities are found throughout the dimensions of the AI lifecycle. They include human-centered design and practice methodologies, promoting the active involvement of end users and other interested parties and relevant AI actors, incorporating context-specific norms and values in system design, evaluating and adapting end-user experiences, and broad integration of humans and human dynamics in all phases of the AI lifecycle. Human factors professionals provide multidisciplinary skills and perspectives to understand context of use, inform interdisciplinary and demographic diversity, engage in consultative processes, design and evaluate user experience, perform human-centered evaluation and testing, and inform impact assessments as well. And in every phase of the AI lifecycle, we have domain experts who have specific experience specialized to the context at hand. Domain experts' tasks involve input from multidisciplinary practitioners or scholars who provide knowledge or expertise in and about an industry sector, economic sector, context, or application area where an AI system is being used. AI actors who are domain experts can provide essential guidance for AI system design and development and interpret outputs in support of work performed by TEVV and AI impact assessment teams. Since risk is measured in impact, we also have to be concerned with roles that go to the AI impact assessment category. AI impact assessment tasks include assessing and evaluating requirements for AI system accountability, combating harmful bias, examining impacts of AI systems, product safety, liability, and security, among others. AI actors such as impact assessors and evaluators provide technical, human factor, sociocultural, and legal expertise. And we have other roles within the AI lifecycle concerned with procurement. Procurement tasks are conducted by AI actors with financial, legal, or policy management authority for acquisition of AI models, products, or services from third-party developers, vendors, or contractors. And as we'll soon find out in the coming module after the introduction, we'll begin by looking at AI governance. AI governance and oversight tasks are assumed by AI actors with management, fiduciary, legal authority, and responsibility for the organization in which an AI system is designed, developed, and/or deployed. Key AI actors responsible for AI governance include organizational management, senior leadership, even the board of directors. These actors are parties that are concerned with the impact and sustainability of the organization as a whole. And since AI can either facilitate that good end or potentially destroy it, this again goes to show that even at the board level, we need a certain understanding of AI and risk to be able to manage the potential good or bad impact of AI to the organization's mission and objectives. So NIST also provides in the AI Risk Management Framework Playbook a really handy roadmap of AI development and adoption. It actually also includes roles and responsibilities that need to be assigned and performed at each sequential phase of that roadmap. So as we look at this, we can see in the plan and design phase, we will have certain activities where we articulate and document the system's concept and objectives, underlying assumptions, and context in light of legal, regulatory requirements, and ethical considerations that will then need to be performed by representative actors that I've talked about in previous slides. Our system operators, end users, domain experts, AI designers, and so on. From planning and design, we progress to collecting and processing data. This is where we gather, validate, and clean data and document the metadata and characteristics of the data set in light of the organization's AI objectives, legal and ethical considerations. These activities are performed by our data scientists, data engineers, data providers, domain experts, sociocultural analysts, human factors experts, as well as our TEVV experts. We then progress to the dimension of AI modeling. And you may remember that AI modeling actually has two life cycle stages: building and use model, as well as verify and validate. So within the build and use model, we have activities that include creating or selecting algorithms, training models. And again, with verify and validate, we also have verify, validate, calibrate, and interpret model output. And this is all performed by modelers, model engineers, data scientists, developers, domain experts, with consultation again of sociocultural experts and analysts who are familiar with the application context, as well as with the TEVV experts. We then progress to the deploy and use lifecycle stage. This is where we pilot the new AI system. We check compatibility with legacy systems. We verify regulatory compliance, manage organizational change, and evaluate the user experience. and this is performed by our systems integrators, developers, systems engineers, domain experts, procurement experts, third-party suppliers, our C-suite executives, along with consultation from our human factors experts, sociocultural analysts, governance experts, and of course our TEVV experts as well. And as I explained, once we have deployed the system, we are now ready to operate and monitor that system. And this is where we operate the AI system and continuously assess its recommendations and impacts, both intended and unintended, in light of objectives, legal and regulatory requirements, as well as ethical considerations. This is all performed by our systems operators, end users, and practitioners, AI designers, impact assessors, TEVV experts, product managers, compliance experts, our governance experts, organizational management, impacted individuals and communities, as well as our evaluators. We now move to our final life cycle stage, where we have to consider, well, the impacts of AI on our people and planet. This is where we assess the use or impacted by life cycle stage. So this is where we actually perform use system and technology. We monitor and assess impacts. We seek mitigation of negative impacts, and we advocate for human rights. This is performed by end users, operators, and practitioners, impacted communities, the general public at large, the policymakers, standards organizations, trade associations, advocacy groups, environmental groups, civil society organizations, and researchers.